And we want to put since the p-value. This is nothing new from the last class, but hopefully it's starting to sink home a little bit more. Of or is smaller than alpha. Oh, that was a nice alpha. We reject the null hypothesis. And just like Brandon was saying before, don't you think we need to put in there what they need to do, or look at that problem and see and put it in context now as to what we accept? Or better yet, we've rejected something, so what else can we conclude? So we want to look back at the problem and say we can conclude what?
Not good evidence.
The proportion is not 0.73, right? So let's say that the proportion, and we could make this really long by saying the proportion of all first-year students at this university who think being very well off is important. We could put it all like that, but why don't we put it a little bit shorter? We can conclude the proportion of students differs from the national average. Don't put like is smaller than or is greater than. We just proved that it's not 0.473, and it's not feasible for this university to fit with that either.
So there is sufficient evidence to suggest that they differ from the national average?
Yes, that there is sufficient evidence to put in there. I should probably put that word in.
So if we reject the hypothesis, there is enough evidence.
There is enough evidence to show exactly. It's like innocent and guilty. There's enough evidence to do the second, to convict someone of the crime. If this was a bigger number, we'd say there's not enough evidence to show that it doesn't, that person is innocent. Even though they might be innocent, they might be guilty, but we don't have enough evidence to put in there. So you're absolutely right. Yes, sir.
So it's under 0.25 rejected. If it's
Yes.
above, we accept. And when you
Well, no, you don't
fail,
want to accept. You just want to say you failed to reject.
fail. Okay.
You failed to reject because we're saying that we, just like what Tom was saying, there's not sufficient evidence, or there's not enough support done for us to say that it's not right. It might not be right, but we don't have enough evidence just yet for it to say. Especially if it's like 0.053. You know, like real close to it. Let's hear it, Tom.
If it is above that 0.05, wouldn't there be enough evidence then? You're saying that could happen?
Yeah, well, it says, the way you were wording it is, there is sufficient evidence, right?
If it's less than 0.05. But then wouldn't there not be sufficient evidence? Because you're saying it's impossible that it happened?
Let me see. Hold on one second. When I talk to the wording of it has to be a special way. Let me see if you can change this when I wrote it down. There is sufficient evidence, or there is not sufficient evidence. I would be changing that. If there is sufficient evidence, like for this one, we have sufficient evidence that
First, so it still makes sense.
yeah, it depends on how you would word it. There's sufficient, for this one, there's sufficient evidence to prove that this is incorrect, or that that's not plausible. Do you see what I mean? There is significant evidence to prove that is correct. Okay, so it depends on the way, like the way you're thinking of it, because one's right and one's wrong. So the way you word it is put into there. So let's review confidence intervals for a second with the same information. Because I'm thinking that we're going to confuse the two things. This is all going to be based on that 0.66 pretty much. Whereas this past one was all based on the 0.73 national average. So if you don't remember, this is where hopefully I'm going to, sorry about that, I'm going to jog your memory about doing a confidence interval again. So right now, we know that we rejected this idea. So let's look at it again. We're going to try a confidence interval and see what the range is for the true proportion. and see if this is going to fit within there. So we still need the same information for that confidence interval, which was 0.66. That hasn't changed. But you can't use the standard deviation from above. You can't really use a lot of the work from above at all. It's all going to be based on this statistic right here. So do you remember what we were doing before?
And
Well, we wanted to make sure that those conditions are met, the random, the normal, the independent, which it's the same information from the top one, so we know that works. But this is the one with the p-hat plus or minus, and the z-score times the standard deviation. Something like that. Hold on 1 second. I want to put it in there correctly.
Yeah, it's just-
And we talked about why we don't use theta within there. So, something like that. This is all with that 0.66 throughout it. So we're not going to be using 0.73 too much within it at all. It's all going to be within this whole 0.66. So that's why I want to make sure that I show you the difference between them, because it might get kind of confusing. This one is all based on what this information was that you received from the statistic. It was the 132 out of 200 first-year students. So a z-score, we need 95%. Remember, the z-score is going to be 2 standard deviations away, or pretty close. I think if you look it up, I think it works out to,
1645.
I think that one's the 90%. I think it's the 1.96. If you look in your chart, you can see. We could do 2, which would be a pretty close estimate, because it's 2 standard deviations up and down. But I think it's closer to 1.96. And again, you can use a calculator to get this. Your Inspire will calculate it for you. I don't want to show it to you just yet, because
It tells me about the chart what it
it tells you right in the chart, right? And it's on the T-chart too, right? At the very bottom.
is. The exact one.
Like, if you look right along the bottom, it'll say 95%, right?
Yeah, whatever you have to use.
And right above it, it says, does it say 1.96?
Yeah.
Yeah.
Perfect. Okay. And this one, we got to do the standard deviation formula, but it's with the 0.66. So that's why I'm saying you can't carry any of that information down from before. 0.66 and 0.34, I want to say. The reason we're not using 0.73 is that's the true mean for this. Like, we're trying to see whether, if that's the true mean, would it fit within here? Doesn't work? Doesn't fit? Or you're talking about something different? Something about something different. It's all right. No, I just wanted to know. I think the standard deviation is pretty similar, 0.03, but this one was 0.031. This is 0.033, so it is going to change things just a little bit. So remember, we're going to have a top value and a bottom value. So that's the goal. Is when you get that interval, you want to get the top value and the bottom value. And you'll notice something once we get it. If we add this to it, I'm going to get 72 point something, I want to say. 72.5. Actually, 72 point maybe 6, if I round it better. Bottom one, 594. So take a look up at the question. 73% of the first-year students at this university is 73.73 within the 95% confidence interval. Okay, so take a look at the first question. We rejected it when we were doing the significance test. When we do the interval, again, we kind of reject it because it doesn't fit within that interval. You're looking for 0.73. Would it be contained within there? No, it's not in there at all. it's still too big. So that's another backup for why we're going to reject it, or why we don't. It's not included in that. Why it just cannot possibly be part of our confidence interval. 95%. It's not in the bulk of the 95%. If you want to put another sentence with this to practice with that, we were putting something about the
90%
the 95% confidence interval. Doesn't contain .73 or something like that. But I think we were saying contains the range from
captures the true
proportion. The true proportion, if it's .73, then it's not in there. So it's another reason to reject it. But I want to make sure that we kind of reviewed these two things, because you can see how they're very similar and they're testing the same type of idea, but one is always using that statistic of .66 and the other one's always pretty much using that national average. Okay, and I'm going to look into that, Brandon, as to why we use the national average. I'm sure I'll be able to find out in a second, instead of throughout the whole problem. I think it's all based on the true mean, but we'll see what happens. So what does this 95% confidence interval tell you about whether the national value holds at this university? It doesn't. Okay. You put it in mathematical terms. I know it doesn't, because you rejected it on so many levels that we're looking at it. It didn't. We rejected at the top, but also kind of this. .73 is not within that interval. So that's another reason why we would say that it doesn't hold true at university. So hopefully that's a little recap for both of those ideas. It's not anything new today. We're going to practice some more. And I have the problems on the Moodle. I also have the next quiz up on the Moodle, 9.2 on the Moodle, and you'll be able to do both of these ideas. And the test, I've got all the things that I want to have accomplished, and I'm done. So you've got 45 minutes to accomplish that. Okay? And then if you don't